802.11 AC. In this chapter, we will discuss about the advantages of .11 AC and a very cool technology of multi-user MIMO, which was introduced in .11 AC Wave 2. Now, up till now, in .11n, since we had multiple inputs and multiple outputs, we used to call that MIMO, which is how sometimes .11n is also denoted with MIMO. But with .11 AC, we introduced a concept of multi-user MIMO, but that was in wave 2. So .11 AC was released in two waves. One was wave 1 and the other was wave 2. We will discuss about this as we go along. But you need to know that .11n was called MIMO, whereas in .11 AC, we have introduced a concept of multi-user MIMO. Okay. So some advantages of .11 AC is what we did in .11n, we had channel width introduced, right? We had something called modulation, which was 64 QAM introduced. We had more spatial streams, of course, right? Which was like 3x3 we talked about. And of course, we used to call it MIMO anyway, but in .11 AC, we took advantage of what we were introduced with .11n, and we made it better. So in channel width here, we made channel width from 40 to 80 to 160, and then modulation also became better, and then spatial streams also were introduced. More spatial streams were also introduced. So we'll discuss about that here. Let's see the difference between .11n and .11c AC in a nutshell. The first and the foremost is that .11n is in 2.4 gigahertz and 5 gigahertz, whereas .11 AC is only in 5 gigahertz. We do not see .11 AC protocol in 2.4 gigahertz. The second difference is in .11n we had lesser spatial streams. Yeah, we had 3x3, right? But in .11 AC, we can go all the way up to 8 spatial streams in wave 2. That's an advantage. In .11n, we had modulation of 64 QAM. In .11 AC, we have the modulation of 256 QAM. The fourth advantage is that in .11n, beamforming was introduced but not used, right? But not widely used. Now in .11 AC, we have something called multi-user MIMO, which uses beamforming, and there is a specific type of beamforming defined, which is called NDP beamforming. That is null data packet beamforming. We'll discuss about NDP beamforming in detail in a video, but for now, the fifth advantage or the fifth difference, I would say, in .11n we had up till 40 megahertz of channel width, whereas in .11 AC we can go all the way up to 80 megahertz, which means combining 4 channels together, and this is in wave 1. In wave 2, we can go all the way up to 160 megahertz. Guys, the standard supports 160 megahertz, but it doesn't mean we need to go and configure 160 megahertz. It is supposed to be configured under extreme special scenarios. You cannot just configure 160 in a normal scenario, because you're combining 8 channels together. If you have total of 24 channels, combining 8 of them will give you 3 effective channels, and we don't want to go down that road. So in a very special scenario, we need to actually deploy 160 megahertz when we have very clean channel, we have less APs, we have less clients. That's when this will be more advantageous to us. Otherwise, moving it to 160 can actually have an adverse effect on the network. So let's not do that, even though the standard supports it. But let's stick to 20 to 40, not go to even 80 or 160 at all, right? Cool. So these are some basic differences between .11n and .11 AC. We're going to talk about all of them, but in the coming next video. Thank you.